Okay, so this is from section 7.4, and we want to sketch this curve that has this particular equation, x to the 2/3 plus y to the 2/3 equals 4. And if we go to sketch that, one of the things to think about, like when you're using your calculators or any kind of technology stuff, is lexicograph functions, right? So we need to solve this thing for y, and that's going to be y equals, what, 4 minus x to the 2/3, all raised to the 3/2. Now, because we have square roots here and we've got things squared, we're going to have to reflect this thing about the x-axis and the y-axis, right? The square root tells me I'm going to need to reflect about the x-axis because we have the positive and the negative, right, of the outputs. But because we also have this thing squared in here, I know I can reflect about the y-axis, because negative values for x are going to give you the same thing as the positive values, right? So I only need to worry about, when I do my sketch, from 0 to whatever, right? And I might also want to know where the intercepts are. So if x equals 0, then that's going to be what, at 8, okay? Because we're going to have 4 to the 3/2, okay, when x equals 0, and that's going to be 8. And well, due to all of the symmetry and stuff, if I do the x-intercept and put 0 equal to this and solve, we're going to have 0 equals 4 minus x to 2/3. So x to the 2/3 is going to equal 4. So x is 4 to the 3/2 again. So that's going to be 8 over here. And that function is going to look like that. But because of all the symmetry, we reflected about the x and the y-axis, and we have this shape. Okay? So what we want to do then is we want to find the length of it. All we're going to do is find the length of this piece, okay, and then multiply it by 4. So I'm going back to looking at the derivative, right? So just so I can have some space here and I can keep some stuff on the screen, I'm going to erase that. So my derivative is going to be 3/2 times 4 minus x to the 2/3 to the negative, subtract 1 from that, so that's going to be negative 1/2. And then we'll multiply by negative 2/3 x to the negative 1/3, because that's the derivative of the inside. That's y prime. So we can simplify a bit and notice that this and this are going to cancel out. And that's going to leave me with x to the negative 1/3 times 4 minus x to the 2/3 to the negative 1/2. Okay. Now I'm doing the arc length, so I'm going to square that, because that's going to be part of my little formula, right? So that's going to be x to the negative, and I should have had a negative here though. So that's going to be x to the negative 2/3 times 4 minus x to the 2/3. When I square that negative in front here, of course it's going to be positive because I'm squaring stuff, right? And that's going to be, let's see, squared, that's going to be negative 1. Oh, wait a minute, I've got a mistake up here. That's 3/2. I don't know where this negative came from, but right here, that shouldn't have been there. That's a positive 1/2, right? So that's a positive 1/2. There we go. So that's 4x to the negative 2/3 minus 1. Okay. Now, when I use the arc length formula, we're going to go from 0 to 8, and we're going to multiply that one by 4, because we have 4 of those pieces, right, using the symmetry. Okay. That's going to be the square root of 1 plus 4x to the negative 2/3 minus 1 dx. So 4 to 8, and that's going to be, well, just 4x to the negative 2/3 dx. Remember, that's to the half, right? So that's just going to be 2x to the negative 1/3. I'm going to pull that 2 out in front just to make things easy. And we'll go from 0 to 8. Now, of course, at 0, we're actually going to have to worry about the limit because that x it's 1 over x to the 1/3, right? So this is really going to be limit as t approaches 0, the integral from t to 8, x to the negative 1/3 dx. And let's see, limit, so t approaches 0, we'll add 1, that's going to be to 2/3, divide by that, so that's 3/2, evaluate that from t to 8. Okay, so at 8, 2, 4, and I can't read my own writing here, so that's 3/2. So let's see, at 8, if we put 8 in there, we're going to have 2, 2 squared is 4, so that's going to be 6, okay, minus 3/2 t to the 2/3. Now, when that limit goes to 0 here, okay, that's going to give me 8 times 6, which is 48. So the length of that curve is 48.